Welcome everybody. It's a sunny Saturday in Sydney at the moment, and the planets are aligned above our heads, and we've just passed the opposition of Mars. Now, if you've been reading been to a newsletter or visited the Binocular and Telescope website, you realise we've got articles currently up talking about the opposition of Mars. We talked about why it's a good time to see the planet, how we are located in terms of our orbits around the solar system. So today what we're going to do is something a little bit different. We're going to have a talk to Dr. Jon Clarke, who's the president of the Mars Society Australia. Hi, John. As many folks would know, as a bit of a disclaimer, I'm also on the board of the Mars Society, and John and I have known each other for some years. But really what I wanted to talk to John about today was a few things, particularly around this idea of space flight to Mars. So welcome, John, and look forward to having an informative and interesting discussion. So I think the first thing to kick things off is I remember as a small little child the Apollo missions, and at the time it seemed that we carried out this insurmountable task of getting to the moon, and we got to the moon 1972, December 1972, last mission there, Apollo 17, and then what happened was we didn't go any back, and we certainly didn't go any further, and everybody I think thought, well, we'll be on Mars by 1980. So what was the cause, do you think, of the lack of, and things like the shuttle program and the space station, but notwithstanding, what do you think perhaps, John, was the cause of human beings not exploring any further, or certainly not going beyond low Earth orbit?
I think there are many reasons, but personally, I think that failure of imagination on behalf of particularly the political circles in the US, and also their perception of the public and influence of public opinion on those political perceptions. So, you and I mean, we saw Apollo landing on the moon, and and I think people like von Braun, basically saw that as just the first stage in human expansion into the solar system. But when you look at Kennedy's statement, putting people on the moon before the decade about and returning them safely to Earth, that was actually the goal of the Apollo program. And once people had landed on the moon, and once they've been brought back safely, that was all the politicians were interested in. So I think in some ways, we should be very grateful we got as many Apollo missions as we did. I know it's fewer than were initially planned, but the fact that we got 6 moon landings in total, 6 attempts at landing on the moon in total, is something we should be grateful for, because the politicians could have said after Apollo 11, okay, we've been there, done that.
Beat the Russians.
We'll stop.
Beat the Russians.
Beat the Russians.
And at the time, yeah, and the task of going further was never a political one at that point, I suppose. Like, there was no real rush to then go further. It's not as though the Russians were racing to Mars, or for that matter, even going a bit further out into the solar system and exploring. And I should point out, as I'm sure many of the folks would know, in relation to bodies in the solar system where human beings can possibly put their feet on the ground, certainly Mars is it for now. Venus, too hot, and the pressures there are just enormous. We have trouble landing spacecraft there that last more than a few minutes. Mercury is too close to the sun. And I think unless there's major revolutions in I suppose, spacecraft propulsion, things like the moons of Jupiter and Saturn, won't happen in our lifetime, and I doubt whether they happen in our children's lifetime. So that's a major technological hurdle. But what was one of the things we hear about when taking, I suppose, the next step, in other words, making the next big leap to, say, go to Mars, is we sometimes hear this idea that Mars is like a second chance at human civilization, like a plan B almost. Is that a viable reason to perhaps explore Mars, or perhaps is it more a case of we really want to go there for exploration and find scientific purposes, and the folks are saying, oh, we've got to have a foothold somewhere else, and perhaps a little bit really using those as an excuse for the missions.
I mean, talking around the traps, you encounter a great many uh, reasons that people have for going to Mars. For some people, the idea of setting up a new outpost of civilization, which will eventually become an independent civilization to what we have here, is very important. But there are other reasons. For some people, it's a opportunity to expand commercial activity. And one of the interesting things that I've noticed, and perhaps you as well, when I joined the Mars Society back in 2001, basically people were inspired by, say, the vision of Arthur Clarke or Carl Sagan, which was a very visionary perspective. Now everybody wants to be Elon Musk, which is a very much sort of an entrepreneurial perspective. And that's not wrong, but it's these should be complementary and not alternatives. Other people see it, Mars, if you can settle on Mars, that becomes planet B. That can become a problem too, because particularly when you've got sort of fairly tough-nosed capitalists driving the idea, people then who are concerned about the ruthless capitalism then say, well, it's just an excuse for wrecking Earth and then moving to the next planet, which actually isn't what it's about. But for some people, planet B is very important. I think both the outpost of civilization and planet B ideas are interesting and exciting, but premature. We've got to get there first. We've got to find out how we can live on Mars, and particularly long-term goals like can people live out their lives, healthy lives of reasonable duration on Mars? Can we give birth to healthy children there and raise them there? These are the questions that need to be addressed before we start thinking about these, seriously thinking about these sort of visionary goals, which are fine as science fiction and inspiring people, but really shouldn't be our focus in the short to medium term.
Got to get there first. Yes.
We've got to get there first, and we've got to address these questions. We've got to explore Mars for, are there signs of life? Well, was there life there? Is there life there? How are we going to do that? What are the various ethical issues? I mean, it's rather like Antarctica. People have been going, wintering over in Antarctica for 130 years or thereabouts. But apart from a couple of Chilean and Argentine stations, none of these are actually settlements that we have there. They're research.
Live there, yeah.
Yeah, I mean, there's an Argentine station and a Chilean station where, for political reasons, children have been born there, children have been raised there. There are schools there. There are churches and all the accoutrements of civilization, even shops. But for the most part, these are research outposts, political outposts. And maybe Mars is going to be that for a long time, until some of these basic questions about the habitability of Mars from a human perspective are answered.
And you raise an interesting point too about life on Mars. And I mean, it's, going back in science fiction days, from into the previous century and perhaps even before, this idea of Mars as being a place where people could live, but not just people, other forms of life. Now, those sorts of sci-fi concepts and those sorts of sci-fi ideas have moved a little bit, I suppose, in terms of our scientific investigation away from pure fantasy to being serious topics of endeavour and research. And John, of the current, I suppose, missions in terms of robotic rovers, which are pacing around the surface of Mars at the moment, the Perseverance rover, for example, springs to mind. One of those, one of the main aims of a lot of these missions is to look for signs and habitability of life on the Mars surface. And so, what have we found there? And realistically, what are we looking for? Is are we looking for current life, or is it signs of past life or fossil life? And if we find something, how does that then impact, I suppose, here on Earth and for us exploring the red planet ourselves?
Mm. Well, we can both remember 1976 when NASA sent two Mars landers, Viking 1 and Viking
Vikings,
2,
yeah.
to Mars, and one of the chief goals, not the only goal, was to actually search for microbial life, to look for signs of microbial metabolism in the soil. And the results were, at best, ambiguous.
Mm.
And I think there was a sense in many scientists in post-Viking, some within NASA, and certainly I think in the political sphere, that people have got their fingers burned doing
Mm.
that. We just didn't know enough about what was going on in the Mars soil to actually answer that question meaningfully. And for those of us who have actually worked in areas of soil science, I'm a geologist, realize that there are a lot of things they could have done testing the soil that would explore reactivity, chemistry, mineralogy, and so on, which they could have done, but which they didn't, and perhaps should have been done before they started looking at signs of metabolic activity, which is a reasonable approach, but you're very much driven by the underlying assumption behind those experiments. And what people don't realize, and I didn't realize until I went back to read the original papers, there are only a handful of these experiments done. Maybe 2 or 3 runs of each test. And that's a very small number of tests to do to answer such a significant scientific question. So since then, the research goals of landers have been either simply characterizing the Martian environment or characterizing aspects that could, not whether or not Mars is habitable, but whether, inhabited, or whether or not it's habitable. And so we had the mantra that NASA followed for over a decade, of follow the water. We've answered that. There is abundant water in the form of ice and hydrated minerals on Mars. We then had to follow the carbon, and we found signs of carbon compounds on the surface of Mars. But the areas that are truly potentially inhabited, for the most part, have been avoided, simply because for that you need to start sterilizing the probes, need to start sterilizing the tools, and that becomes very complex and very very expensive.
And we've discovered from missions going back to Apollo 12, where they brought back parts of the of previous robotic landers that had plonked themselves nearby, that Earth microbes, no matter what we do, are very, very sticky. So
Yeah.
we want to make sure what we go there with is not spreading life form from Earth. We want to check out what's there. So
And even
so
those,
really,
sorry, go ahead.
yeah, I was going to say. So what I suppose we've got to do, as you said, we've got to make sure if we go to places that we think might have high chance of fossilized life itself, we need to really make sure we've put these things through the big car wash and have gotten any sign of life from themselves. But even so, are we expecting to find say subsurface where, as you said, we've discovered there does exist water on Mars? Do we expect to find current life there, or are we just thinking this has now been too long? It's been without an atmosphere for too long, and with we're just basically going to find, if we're lucky, fossils of microbes? Or do you think there's still hope of finding life that's currently alive and breathing?
My own view as a Mars scientist is that we have found that early Mars was certainly inhabitable, right? That their early Mars, the atmosphere was much denser than it is now. It was probably mostly carbon dioxide with some nitrogen, slightly
Surface.
more oxygen around than there is at present, and the answer and the reasons for that we don't know. There's certainly organic carbon around and being trapped in the rocks. We know that there was open water on the surface of Mars, and a paper that just came out last week showed that there was no, some of these open water bodies at least showed there was no sign of ice present. So this was equitable temperatures. This wasn't a sort of an Antarctica type scenario on
You could live there.
Mars. This was
put your 10-10 on the
Yeah,
edge of the Mars stage.
quite remarkable.
Yeah, it
Yeah.
was. Yeah.
So great
And
win, a great win for applied symptomatology.
yeah.
So early Mars, yes, potentially inhabitable, potentially inhabited, but we don't know.
Mm, mm,
More recently, I think it's still possible that in areas on the edge of permafrost, the upper edge of permafrost, when it might thaw out briefly in the summer, are potentially inhabited. But we haven't actually tested any of these areas very well.
mm, mm.
The one
So
Phoenix Lander did do that. Again, and found all sorts of weird results, but nothing conclusive.
mm.
Um,
I mean, we
and
go.
of course, when you send to Mars, when you send something to Mars, there are all sorts of different people who want to have their bit of science done. You end up with a compromise. And of
Mm,
course, the people who want to look for life are just a subset of that. And experiments are often very, very complex and hard to do. I mean, one of the things that we keep forgetting, we're in love with the robots, and it's a relationship that needs to be much more constrained than it is, because they are incredibly slow, they're incredibly limited, and they're very much driven by the assumptions of the people who send them. Because once you send something to Mars, you can't then tinker with it and change it because the
that's what
assumptions
it's
have
going to
changed.
do.
It's
Yeah,
got to
yeah. Mm,
exactly. And so a classic example was the an InSight lander that went to Mars a few years ago to set up a geophysical observatory. It took months just to pick up an object on the deck and put it on the ground, the seismometer, and
mm,
then put a cover over it. I mean, stuff that you and I would do if it was in the garden in 5 minutes, if that.
mm,
Yeah.
mm,
But it took this wretched robot months and months to do that. And the more complex the task, the longer and slower it is.
mm.
So, and I
Yeah,
think some of these scientific questions are require such complexity and flexibility in their execution that to try and do it robotically, where you've got an uplink in the morning, downlink in the afternoon, and it's a multi-billion-dollar mission, and nobody wants to risk it by doing the wrong thing, certainly becomes almost impossible to do. And that's where the human dimension of having humans on the surface starts becoming feasible
mm.
and probably
Absolutely. And
very
it's interesting to talk to people, and talk about, say, the Perseverance rovers and rovers currently like that they don't scoot around like a golf cart or a little buggy. These things
no.
crawl at an amazingly slow rate, like centimeters almost sometimes per day. So it's a very, very slow
Yeah.
process, as you said. And that, I suppose, that leads us on to the question about human beings traveling to Mars. When going back again a couple of decades ago, that was just absolute fantasy. And now we have two space programs, both, and they are interlinked to some degree, both the Artemis program, which is part of NASA and the US government with a lot of other countries involved, and also the SpaceX a company headed up by Elon Musk, both of whom have said, and as I said, they do work together quite a lot, both of whom have stated aims of taking people to Mars. Now, SpaceX particularly have said that the 2028 launch window, and maybe you might want to talk about why we have these launch windows to Mars, the 2028 launch window, they will send a fleet of starships, the ones that they are both launching, or mainly launching, but sometimes blowing up at the moment. And if they are successful as uncrewed missions, 2030 is the date to put in the calendar when human beings will climb into a spaceship, light the wick, and head off to the red planet. Now, that's a vastly accelerated time frame, and I don't think anyone seriously thinks that's going to happen. But at least for the first time, there's a line in the sand where we've said, okay, we're going for it. So, how do you think, like, there's this sort of delayed approach, in the sense we go via certain windows when our orbital elements make a short trip. The other thing is, if we want to bring people back, they have to stay there for a certain amount of time as well. So it's not like the Apollo mission where you go and spend a few days, fire the rocket, come back to Earth. So you have to, in some ways, learn at least some degree of living there for a period of time. So do you think this is going to happen
Mhm.
in that sort of time frame, or do you think it might blow out another few years? It's a tricky one, and I don't think anyone really knows.
I mean, if we put our mind to it, we'd be on Mars in 10 years.
Oh, yeah. Mhm.
And that's been true, sadly, for the past 20, 30 years. That if we really
Mm.
put our mind to it, we could be on Mars in a decade. Um, whether politicians from whatever country, a consortium of country, or even business people are prepared to do that, I think is an unanswered question.
Mm.
I personally, I do not think that any entrepreneur is going to blow their, no matter how big their fortune, they're going to blow it all on sending people to Mars. I mean,
Mm.
the SpaceX has done a really good job with their Falcon 9 rocket, with the Dragon spacecraft, with launching satellites. Um, but the Starship program is, to me, and I'm not a rocket scientist, I'm just a space scientist with an interest in how that works. To me, I look at that and it's almost Keystone Cops.
Mm.
Building giant rockets outside, when these days we don't even build ships outside for the most part.
Mm.
Launching them, knowing they're not ready, knowing that they're not fit for purpose, and then cheering from wildly, or the fans at least, cheering wildly as they blow up spectacularly. I mean,
Mm.
it isn't, to me, the way we want to go into space. I mean,
Mm.
it's sort of it's like the ancient Roman idea of sport, bread and circuses, and the more blood, the better.
Mm.
I mean, sorry,
Yeah,
I,
look,
I,
I think a
try
lot of
hard.
people agree with you. A lot of
I
people agree.
try, yeah. I try hard not to have a pufferfish reaction to Elon Musk and just sort
Yeah,
of blow
yeah.
my blow up and just sort of mutter incomprehensibly. Um, there's just so many concerns of how he wants to go about it.
Mm. Mm.
Even the whole mission architecture is just nuts. Refueling in orbit. Why refuel in orbit? Well, we want to get there in 4 months. Why do you want to get there in 4 months? Well, because we think it's better to get there. The faster we get there, the less radiation exposure. Well, that's true, but we are routinely putting people into space and have been for decades, for 6 months and longer on the International Space
Mm.
Station, now the Chinese space station. It won't kill them to spend
Mm.
6 months traveling to
All right.
Mars. And then why is it going to be so big? Oh, because we're going to use it to settle people on Mars and send lots of people. Well, it's so darn big that it's going to excavate a huge hole in the Martian surface when it lands, and it'll probably topple over, or the engines will be so badly damaged they won't be able to be flown to bring people back. Yeah, yeah. Just
Yeah,
in every decision made with Starship is based on assumptions that are problematic.
yeah. And I look, I
I could
think
go on to this, I won't.
and I think I tend to agree with you on that. Perhaps a more nuanced approach is the Artemis program, which
Hmm.
NASA is putting a staged approach both to expansion, but a little bit more about that living in space thing with moon bases and taking things a bit more slowly to Mars. But look, maybe not. So in other words, maybe not 2030, and maybe not have to spend the some quite a few months there before they can come back. But I think it's people are making the progress, and I think that's the thing when we go
Oh, yes.
outside tonight and put our heads up and look at the red planet that's shining very brightly at the moment, that there is a possibility of two things. One is that there could have been life there in the past, and I think that's got
Mm,
a fairly deep impact on the human psyche when we consider that for a period of time.
mm,
And the second thing is that we will eventually, in the years to come, maybe not as few as we would like,
mm.
but we will eventually see people there. And just to go back to your point as well
Yeah,
about the political will
absolutely.
to do it, we don't need new technology to go there. So there's nothing that we need to discover or find things that well, we've got this going, but don't really know how to do this little bit. All could be overcome. There's nothing there that if we decided to do it,
Mm.
humans at their current state
Yeah.
of development could do. So we don't need to
But
invent some.
that's something we've learned in the last 20 or 30
Hmm,
years of
hmm,
doing things with the International Space Station, the Space Shuttle program. the Chinese space station. We've learned how to live in space for the required lengths of time. We've known how to maintain, build objects that are spacecraft, complex human spacecraft
Mm.
that are reliable over the length of time. We can service them when they need replacement or updating. We can fix them when something goes wrong. There's been enormous experience. I mean, there is no, as far as I can see, there are very few biomedical questions which are unanswered at this stage. The technological questions, we can navigate to Mars. We know the surface properties of Mars, of how driven in robotic vehicles tens of kilometers across the Martian surface. They've lasted for decades. Some of them have lasted for decades. It's not as if the hostility of the Martian surface is very well constrained. The only real areas that are poorly understood at this stage is actually landing a large enough spacecraft on the Martian surface. And I think the success of certainly SpaceX in this regard, in returning very large stages from orbit, has gone a long way. I mean, the Falcon 9, its weight on Earth is the weight of a much larger spacecraft, 3 times the mass on Mars. And we can do that routinely now. It's a tremendous assumption.
Almost every
20 years ago, people were sort of thinking, oh, can we do supersonic retropropulsion? Now it's routine. And also one of the really biggest challenges, though, which I think is still only partly solved, I think it's solvable, is the design of spacesuits. I mean, current spacesuits will not work on Mars. And even if they did work, they're far too heavy. We need to build suits which are far lighter, far more flexible, far easier to put on and put off on the surface of Mars if we're going to explore it with astronauts, because people aren't going to go out once every 6 months like they do in the International Space Station.
No,
people will go out every day. Every day, or perhaps at least several times a week. And current spacesuits just won't allow that. So that's, if people want to look at technology that makes it possible for us to go to Mars, work on spacesuits.
And we have also, we have Australian technology companies working on spacesuits here locally as well, which is fantastic. So, John, look, thank you for your time this afternoon.
I think we've covered aerospace.
Yes, exactly. Yes. We've covered a really wide range of topics, and I think the bottom line is that, as I said, when we head out tonight, look at Mars. It's people, I suppose, get a big buzz out of photographing things now in space and seeing, the results in their cameras and doing astrophotography. But Mars is one of those things that's kind of up close that you can look at through a telescope. It's a star to your eyes. Even a small telescope's going to show it as a ball, particularly when it's in opposition like it's at the moment, and you get to see some features and go, this is our closest neighbor in the solar system that we can visit. We've got technology running around on the surface now. We see pictures from Mars every day, which is really quite amazing in its own right. And hopefully we'll overcome all these hurdles, both, I suppose, business, political, whatever, a few technological ones. And within our lifetimes, and certainly as humanity keeps going, we'll establish a presence there. Not maybe for business reasons, but just because we can. And I think that's probably that's inspiring in its own right. So, anyway,
John, Antarctica in the sky is a great place to start with Mars.
Better describe it.
Look at these amazing images. Yeah, and there's a artist out there, I forget his name, but he takes a lot of the Curiosity images and he puts to scale a little figure of astronaut. He calls her Astrid. And it's really great to actually help us appreciate the scale of these features, which are often very hard to determine, and to remind us that, this is a place people wearing a spacesuit or a Mars suit can walk around on and look up at that cliff or look out at those sand dunes and leave their footprints in the sand. It's an amazing thought. And we look at Mars in the sky, and yes, it's somewhere we can reach. It's somewhere robotically we have reached. There's active spacecraft orbiting Mars. There's active spacecraft on the surface. It's an amazing thought.
And
in fact, every planet we can see with our naked eye, there are spacecraft orbiting them at the moment. Oh,
Exactly.
except for Saturn, and that was we did have one there
We did
quite
have one there for quite
recently.
a while. The Cassini probe did us all proud.
Yeah, yeah,
And I think too that it's fascinating to think that one day someone will be able to be on the surface of Mars, look at this really bright star, perhaps not too far away in the sky
mm,
from Venus, put a telescope in it, and
yeah,
this bright white dot will resolve itself into a white and blue planet, which is Earth. So something to look forward to.
yeah.
All right, John. Look, good to chat to you as always, mate. Appreciate making the time this afternoon,
Yes.
and we'll chat soon.